everybody. So what I'm going to do today is we're just going to look at some density problems that we hadn't covered yet in class. And I wanted to do this via Zoom so you could see the whiteboard function for yourself and maybe encourage you if you ever did want to meet or had questions to have a Zoom meet with me. And this is your opportunity to kind of see how it works because we can work through problems together on Zoom. So what I'm going to be doing is I'm going to start by working on the problem that I have written on the whiteboard that you're looking at, and it's calculating the volume in milliliters of a 10-gram saline solution that has a density of 1.05 grams per mil. Okay, so we touched on density briefly in our last class. And if you were there or watched the video on it, you'll have seen an example or two on density already. I wanted to do a few more just to kind of solidify this concept. So when we're doing a density problem, we're using the, let me get a pen. We're using the density is equal to mass over volume. So that's the equation that we're going to use. And it's helpful to figure out, looking in the problem itself, what two pieces of information we're going to need, and then to identify those pieces. So for instance, this number here, 10.0 G. Okay, that is a mass, right? Mass, 10.0 grams. Figure out how to take off that thing that says that's me writing. All right, so the other piece of information is this 1.05 grams per mil. And that is the density. So you'll notice that we're actually going to have to rearrange that original equation. And I showed in class on the video this triangle with a D, an M, and a V. That will help you rearrange the equation. So if you want to rearrange that equation to solve for volume, which is the case here, you cover up the V with your hand and do the following operations on the remaining two. So if you remember, horizontal lines are division lines and vertical lines are going to be multiplication. So if you cover up the V, the rearranged equation is going to leave just the M and D left. So you're going to take the mass and divide it by the volume, or sorry, the density to solve. So before you do that, you just want to check units and make sure that everything's in the proper units. So we have grams for mass and density is grams per mil. So we're good on units. So I'm going to plug those values in, putting the mass on the top and the density on the bottom. And notice that the units of grams, since they're on opposite sides of a horizontal line, they're actually canceling out. So my units, once I'm done calculating this, is just going to be in milliliters. So I'm going to enter this into my calculator because I didn't do that beforehand. So 10 divided by 1.05. And I get 9.52. So you always want to look at sig figs. So when we're looking at the significant figures, we're looking at the original numbers. So for mass, there's a total of 3 sig figs. Because both the zeros count because of that decimal point. You can't see it. Let me make it a little bit bigger. And for density, there's also 3 sig figs. So that means we want 3 significant figures in our answer. So when I report my answer, I'm going to take what I get on the calculator, which is 9.5238, etc. And I'm going to count out 3 sig figs and round if necessary. So let's look at that. So I have 1, 2, 3. Look to the number next to it. And what I'm going to do is keep that at a 2. So my answer, final answer, we'll write it up here so we can see it a little bit better. It's going to be 9.52 milliliters. All right, so let's try another one. So I'm going to go ahead and clear the drawings and then put another question here. The more I use Zoom, the faster all of this is going to go. So I apologize that it seems like it's a little slow, but practice makes perfect. So stick with me. All right, so here's going to be the next problem that we're going to work on. This one is ammonia, and it's given us a density, and then asking what the mass is for a 6-liter sample. Sorry, do this again. All right, so we're using density again, so we're going to use that density equation. Write that off to the side. We have density is equal to mass over volume. Okay. I'm also going to write the density triangle in case we need to rearrange, which is D, M, V. And now I'll start by writing my knowns and unknowns. So density they gave us was 0.000771 grams per mil. The mass, they didn't give us, right? They're asking what is the mass? So I'm going to put a question mark. Then it says, what is the mass of a 6-liter sample? So that's 6 liters. Liters is a volume, so that's going to be our V. Well, since we're solving for mass, we know that we're going to need to rearrange the equation. So we are going to use that triangle. So this time, we're going to cover up the M with our hand. Imagine this is me covering it up. And we're going to do operations to the remaining variables. What that means is we're going to take density and we're going to multiply it by the volume. The equation is going to become mass is equal to density times volume. Before I go and plug my variables in, my density, my volume, check your units, okay? So you'll see in this case, we have, get a different color here, milliliters, grams per milliliter for the density, but my volume isn't in milliliters this time, it's in liters. Okay, so in order to do this problem, you need the units to be the same. Okay, so you have two choices here. You can convert the density so that it's grams per liter, or you can convert the volume so that it's in milliliters instead of liters. And I think that's going to be a little more straightforward. So that's the approach that I'm going to take. So I'm going to take this 6 liters and I'm going to convert it into milliliters. Okay, and I'm going to use that shortcut that I showed you in the last video, because this is metric to metric, right? We have liters and then milliliters. So if it's metric to metric, there's a shortcut we can use from kilo all the way down to the milli, and that is that KHD DCM. So let me write that over here. What color should I choose? KHD space DCM. So remember, those represent the prefixes in the metric system, from the kilo, the K, all the way down to the milli, the M. The reason we have an empty space is because that is where the unit goes, our base unit goes, depending upon what we're measuring. So we're measuring volume. So what's going to go in that empty space is going to be an L for liters. So now we need to figure out how many times we need to move the decimal point. So to move the decimal point, we're going to start at liters and go to the milli. I'm going to start at the L and go to where the M is, the milli. So how many times do I have to move the decimal to get it there? I'm moving it 1, 2, 3 times to the right. So I'm going to do the same thing with the number present. So the original number was in liters and it was 6.0. So I'm going to take that decimal point and I'm going to move it 3 times to the right, just like I did on the scale on the right corner. So I'm going to go 1, 2, 3. And what's going to go in those empty spaces? It's going to be zeros. Okay, so my volume now is in milliliters and it's 6,000 milliliters. So that's the volume I'm going to want to use in my equation. Okay, we're not worrying about significant figures until the very end of the problem. Okay, so I'm not worried that that's not the correct sig figs in that conversion because that's not my final answer. And that's the only time we need to look back at sig figs. So let's solve the problem now that the units are all the same. Okay, so I'm going to take my mass. So I'm using this equation over here. Solving for mass, I'm going to take the density, so 0.000771 grams per mil, and multiply it by my volume, which is in milliliters now. And the reason I needed it in milliliters is, look, milliliters is in the denominator over here, and it's in the numerator over here. So now milliliters canceled. If I left it in liters, the units wouldn't have canceled. Okay, so now I've canceled my milliliters. My answer will be in grams. When I enter this into my calculator, I get 6,000 times 0.000771. I get 4.626. Well, how many sig figs do I want? So looking back at significant figures, my density has 1, 2, 3. Because the zeros before that 7 don't count. Even though there's a decimal, we can't count zeros until we reach our first non-zero number. So we have 3 sig figs in the density, and we have 2 significant figures underlined in blue there for the volume. So those 2 significant figures are going to determine how many we have in our answer, because you always pick the smallest. So 2 sig figs in my answer will give me an answer of 4.6. My units are grams, because notice that's the only units left when we did the calculation. All right, so let's try another one. Let me go ahead and clear. And then I'm going to make another text box and copy in the last question. So, there we go. I did it again. I don't know what's up with that. If anybody knows what's happening with my text turning into all those symbols, please let me know. I'd love to figure out how to get that to not happen again. But for now, we'll just not close the text box, and that'll solve that problem. Okay, so this next problem, we are calculating mass again. We are given a density, and we are given a volume. So let's start this problem. By writing the variables. So this first number here, the 2.1 times 10 to the negative 2 liters, that's a volume. Okay, so I'm going to write V is equal to 2.10 times 10 to the negative 2 liters. The other piece of information, it's in grams per liter, and it specifically tells me it's a density, if I didn't already know that based off of the units. So 1029 grams per liter. What are we looking for? Mass. That's our question mark. So we can use the same rearranged equation that we used in the last problem. So that was where mass is equal to density times volume. Before we use it and put those numbers in, we want to check on our units. Okay, so in this case, our volume is in liters. Our density is in grams per liter. Now, since the units are the same, we have liters in both, we don't need to convert both of those to milliliters. The important thing is that they're in the same units so that we can cancel them out come calculation time. Okay, so I'm gonna leave it how it is. I'm not gonna create extra work for myself. So now if I plug them in, so I have mass is equal to, I'm gonna plug my density in first, so that 1029, and it's grams per liter. Multiply that by my volume, which is 2.10 times 10 to the negative 2 liters. And then notice, since liters, opposite sides of the horizontal line, they're going to cancel each other out. My answer will be in grams, so all is good there. So let's calculate that, and then we'll figure out how many sig figs we need to report our answer in. So when I put that in my calculator, 2.10 I get 21.609. Okay, so I don't want all those digits, so let's count our sig figs. Let's go to red here. So for the volume, we have 1, 2, and then does that last 0 count? Since there's a decimal and we already started counting, yes, it does. So we have 3 sig figs in the volume. For the density, we have 1, 2, 3, 4 sig figs. You always want to pick the smallest, so we want just 3 significant figures in our answer. So going back to what I have on my calculator, I only want to choose 3 of those and then round if necessary. So my answer becomes 21.6, and that is going to stay a 6, and then my units are going to be grams. That would be the answer for that one. All right, so that is it for the problems that I wanted to do. So I'm going to go ahead and stop sharing that screen. What I want to show you next is going to be what is due in the future. So I just kind of wanted to do a reminder of what's due and then talk about the exam a little bit because that is coming up next week. Okay, so let's show you the PowerPoint. So I'm going to share this screen here. So you should be able to see now your Blackboard shell. Okay, so I just covered density. That was the last topic of the chapter. In the PowerPoints, I gave a whole bunch of definitions. I talked about the scientific method, as well as physical properties, chemical properties, physical change, chemical change, elements, compounds, homogeneous mixtures, heterogeneous mixtures. Okay, so make sure that you watch those PowerPoints, listen to the examples given on the PowerPoints for the concepts and definitions of those, because those will be included on your homework and they will also be included on the exam. Okay, so the homework for this section, because this is chapter 1C that's assigned next week, you're going to go into course content, and that homework covering density and all of those properties is in week 3. So if you look at this, week 3, exam this week. Okay, so the exam is actually due next Sunday on the 13th. I'm going to open the exam up, however, on Friday, September 11th. So you can start taking it starting next Friday, a week from today. So figure out when's good for you, find a quiet space, quiet time, good internet connection, and start your exam. All right, so let's go into this folder. So what I wanted to show you was there's another folder inside that. And see, it says chapter 1C. So this is where your PowerPoints are going to be that I'm talking about with all those definitions. It's where the homework's going to be, and it's also where the discussion board's going to be. So I wanted to point out before I go in this folder that all of this is due Wednesday, September 9th. Okay, So this Sunday, you have your 1B homework due and your discussion for 1B. Then on Wednesday the 9th, you're going to have your chapter 1C homework due and the discussion for 1C. So you can see those two here. Okay, so they are due on Wednesday. So you might want to start them this weekend is why I'm trying to point that out in this Friday video, okay? And then you have, of course, the PowerPoint lecture video. This video that I'm doing right now will be posted in week 2, since that's when I did it. I can also post it here, just so it's in 2 places. Easier to find the more places I put it, right? So I'll make sure to put it in both places. Okay, so that you can do those density problems. All right, so what I want to also point out, let's go back to week 3. Week 2 is pretty much over. Is you'll notice that there are chapter 1A practice exam questions, chapter 1B practice exam questions, and chapter 1C. Okay, so I have them separated into 3 separate groups. These are not graded. Okay, these are for you to practice. You can take them as many times as you want. The reason I wanted to post some is because they are given in the same format as the exam. So when you go to take the exam, you're going to get 1 question at a time. You are not going to be able to backtrack. So once you answer that question and press submit to move to the next question, you can't go back and change your answer. And that's what these chapter 1B, 1C, 1A practice exam questions are. They're in that same format, okay? So I want you to get used to that, not being able to backtrack and just seeing 1 question at a time. So I recommend you do those questions as many times as it takes to get the right answer, okay? Because it's the same material you're going to see on the exam. The exam itself is 36 questions long, and I believe they're all multiple choice except one is, I think, is fill in the blank. All right, so I have a review posted, you can see here, for the exam. So if you click on the review, I left it in Word document form just so you guys could see, fill it in, type it in instead of printing it in case you don't have a printer. So I see it's not showing up on your screen, so let me share my Word document screen now so you can see the document I'm looking at trying to explain to you. All right. So now you should be able to see the review. So I posted a review for the first exam. So there's a define the following section, and a lot of these definitions you're going to get from that PowerPoint in week 3, the 1C PowerPoint, the chapter 1C PowerPoint. So I recommend you go through and write down the definitions for all of these, maybe write down some examples for them as well. I didn't fill them in for you. That's something you can do on your own. When you write down definitions, it actually helps them stick in your head. There's some research been done on that, so I recommend you do that. Write down or type it in. When you get to physical changes and chemical properties, you'll notice I gave some examples of each of those in parentheses. You'll want to write down the definitions and possibly some more examples, okay? Because I'll ask questions on those. I'll give examples and I'll say, hey, is this an intensive property or an extensive property? Sorry, the room I'm in, the lights are on the timer. If I don't move around, the lights go out. So I had to go move, walk around and wave my arms to start them again. All right, so continuing on, make sure you're writing those definitions and some examples. So you can see I have several. Going down to hypothesis, theory, scientific method, okay, states of matter. So one thing I want to point out on the states of matter, you'll want to write, does each have a fixed shape or a volume? So for a solid, it has a fixed shape and a fixed volume. For a liquid, it has a fixed volume, but not a fixed shape. So that's what I'm looking for there. You'll want to write those definitions down. Precision and accuracy. We talked about that in chapter 1, but it wasn't 1C. I think it was 1B. So you'll want to go to that PowerPoint and find those definitions if you don't already know them and write those down. So precision is more getting the same result over and over again. Accuracy is getting the correct result. So look up those definitions and write those down. So significant figures will also be on the exam. So these are just guidelines for significant figures, okay? Remember, all non-zero digits are significant, so these are the rules for recognizing zeros between two non-zero digits, etc. Okay, so you can read those on your own time. I'll leave that to you. It's just to help you in identifying significant figures, which hopefully you're great at by now because we've been doing it quite a bit. Then there's rules for adding and subtracting. So remember, when you add and subtract numbers, when you're counting sig figs for your answer, you're looking at the decimal place only. When you're multiplying and dividing, you're looking at significant figures as a whole. So they do have different rules. So pay attention to what order of operation I'm asking you to complete for when you count your sig figs. For scientific notation and normal notation, you're going to have to know how to go back and forth between that. So I have the rules there that you can review. And then I have conversions. So I put a couple conversions here for you to practice on. And so go ahead and try these problems out on your own. So next week, since I've covered all the topics, for chapter 1, next week's a review week. So we don't have class Monday. So for the Monday people, because this is also a video for the Tuesday, Thursday people. So the other days we're going to review, okay? For the Tuesday, Thursday people, one day will be a review, and the next day I'm gonna start the next chapter. Now the next chapter material will not be on the exam, but I am starting it in the interest of time, okay? So, but everybody, no matter what one of my sections you're in, there will be one complete class period dedicated to review. So bring your questions. I'm gonna be going over this review sheet and doing these problems on the board for anybody that had issues with them. So there are some conversion problems for you to practice, some temperature conversions. There's some density calculations, which we just did. All right, so practice those. I will do those during the review in class. Bring any questions you have for the review if you are an in-class person, or email me some questions. Whatever questions you email me, I'll do on the review and you can see it in the video later, okay? So that works great as well. All right, so I think that is all I wanted to share with you. So make sure that you are getting your Sunday discussions for chapter 1B and your Sunday homework for chapter 1B completed by Sunday at midnight. So it is Labor Day weekend. It's going to be hard to remember, so just do it now. Get it done with. And then your chapter 1C problems and discussion are going to be due on Wednesday. Okay, so just be aware of that. You don't have a whole week to complete them. They're due on Wednesday. And the exam's coming up, so fill out this sheet and start studying. All right. Thanks, everybody. Let me know if you have any questions as always, and I will see you all, whether virtually or in person, next week. Enjoy your Labor Day weekend. Don't spend the whole time studying. Have some fun too. That is needed. All right. Bye.